All right, so today we're going to be looking at the just more of an application specifically to definite integrals in business and economics. And I'm pretty sure in the past, I think I made a comment about how if you have a really solid foundation in calculus, that if you're going into economics, like a field of economics in particular, it's really going to serve you well, because a lot of the advanced economic theory that we look at is heavily focused in mathematics and calculus in particular. So if that is something that you're interested in doing, you're probably going to go and continue to take more math classes. I'm just going to be completely honest with you. So let's go ahead and take a quick look at a few different things. Present value and future value of a continuous income stream. We're going to go through some examples here to kind of explain what specifically is going on. But if you have a function which is a rate of continuous income flow earning an interest rate R, is compounded continuously, the present value of the continuous income stream is going to be the function times e to the minus rt dt, and it's going to be between 0 and k. So that k value right there is just going to be, it's in the context of the problem, so they'll usually say over the next, say, like 15 years. K would be 15 in that case. Or over the next 6 years, it'd be 6, right? So that would be kind of like the important thing just to keep in mind. Future value is pretty much identical to present value. The only difference is that we have an additional little piece kind of sitting out in front. And this specifically deals with some just kind of compounding interest that's being applied as a future value, okay? So let's go ahead and just jump into some of the problems. Now, the context of these problems, you'll see them very, very clearly. Generally, you're going to be looking for present value and future value if it says find the present value and find the future value. If it doesn't say either of those, then for the most part, you're just going to be integrating whatever the function they give you at that time. So, for example, the first question we're going to look at here says find the total income over the next 10 years from a continuous income stream that has an annual rate of flow of time t given by f of t is equal to 12,000 e. So I'm just reading this off. Let me just write it. F of t is equal to 12,000 e to the minus 0.01 t. Okay, and that's in dollars per year. Whoop, and I need to flip to my whiteboard. There we go. Okay. So in this one, because in the context of the problem, they didn't specify present value or future value or anything like that, we're just going to integrate this between 0 and 10. So we're going to have the integral from 0 to 10 of, in this case, let me close these down here to save my computer. There we go. From 0 to 10 of 12,000 e to the minus 0.01. I gotta make sure I get this correct. 0.01 t dt. Okay. And we can use u substitution on this, which I'm just going to do here really quick. So we're going to let u equal minus 0.01 t du is equal to minus 0.01 dt. So 1 over minus 0.01 du is equal to dt. All right, so now as a result, we can go ahead and make that substitution up here. Oh, we do have to change the bounds. That's actually important for us to do as well. So let's go ahead and do that. So for t is equal to 0, so we're starting with the lower bound. We'll go ahead and sub that in, and we're going to get u is equal to, so here, we're going to sub that into there, minus 0.01 times 0, which is equal to 0. How about that? That works out nice. For t is equal to 10, u is equal to minus 0.01 times 10, which in this case is just, was it a minus? I feel like I made a mistake here. Was it positive? Oh, it was positive. Why am I doing a minus here? Jeez. Positive, 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 positive. Yep, that will cause some problems. There we go. Here we go. Okay. So this is going to be 0.1. Okay. All right, so my integral is going to be between 0 and 0.1. And I'm going to have 12,000 times this stuff, 1 over 0.01 e to the u du, which this is going to equal, well, it's going to turn into a bigger number. I think it's going to be, what, 1,200,000? 1, 2, 1, 2, 3, 4, 5. I think that's correct. Yeah. E to the u, because again, it's just the integral is itself, evaluated between 0 and 0.1. And so when you actually go ahead and sub this all in, you're going to get 126,205.5.10. Man, this is freezing up on me. There we go. 126,205.10. So that is the total income over the next 10 years from a continuous income stream that has an annual rate of flow. Pretty cool. All right. Next question. Question 5. A small brewery. Oh, that sounds nice. Small brewery considers the output of its bottling machine as a continuous income stream with an annual rate of flow at time t given by f of t is equal to 80e to the minus, this is a minus this time, so it's not my fault. Okay, so now we do the integral. So again, there's no present value, no future value indicated. We're looking for the income from the stream over the next 10 years. So 0 to 10 of 80 e to the minus 0.1 t dt. Okay. All right. And then we're going to let u equal minus 0.1 t. du is equal to a minus 0.1 dt. So a 1 over minus 0.1 du is equal to dt. Okay. Now we need to do the bounds. So t equals 0. That means that we've got u is equal to minus. There's a minus in there. Whoops. Get rid of that. Minus 0.1 times 0, which is equal to 0. Guess it really didn't matter there. T equals 10. This will be a u equal to minus 0.1 times 10, which in this case is going to equal minus 1. So again, the order matters. So you have to go from the lower to the upper. So this is going to turn into the integral. The lower bound is 0. This is going to be a minus 1. I know it's kind of weird because usually you think upper bound is like a bigger number. That's not necessarily the case here. Okay. In fact, there's a specific property. I'll mention it here later in the end, but you know, so we're going to have 80 times this 1 over minus 0.1 e to the u du. So this is going to equal minus 800 e to the u between minus 1 and 0. Okay. And when you sub all of this stuff in and evaluate, so that's going to be a minus 800 e to the minus 1 minus a minus 800 e to the 0, which in this case, this is going to turn into a plus 800, and I've got that, which is a minus 800 divided by e plus 800, which is equal to roughly 505.696. Okay? And that's our solution. Now, the property that I was mentioning is, so this is kind of like that, this is a little side note here, property. You can actually flip the bounds so they're in the correct order, and then you can just slap a negative in front. So if you wanted to do this, you could do that. Okay? 81 over minus 0.1 e to the u du. Same thing. This right here is equivalent to that. I just threw a minus in front, and that way I could reorder it. So the lowest number was the lower bound, the higher number was the higher bound. Upper bound, I guess. So property, that's kind of nice to know. Anyway, all right. Let's go to the next one. So this is where we start getting into some more like present value, future value kinds of questions. So on this one, they say, suppose a vending machine company is considering selling some of its machines. Suppose further that the income from those particular machines is a continuous stream with an annual rate of flow at time t given by f of t is equal to 12 e to the minus 0.4 times t plus 3. That's kind of a weird function. In thousands of dollars per year. Find the present value and future value of the machines over the next 5 years. Okay? The present value and future value of the machines over the next 5 years. So we have to do both present and future value. So before we do anything here, I actually want to show you something that's kind of important. And that is that specifically when you're dealing with like present value and future value, you have to introduce another e. And so this is kind of a funky looking function. And so I'm just going to change it a little bit. Just multiply that minus 0.4 out. So it's going to be a minus 0.4 t. And then you're going to have a minus 0.4 times a 3. So that's going to be a minus 1.2. Now, why am I doing this? You're going to see in just a second why that is, okay? Because the present value is defined as the integral. In this case, we're doing it over the course of the next 5 years. So find the present value and future value of the machine over the next 5 years if money is worth 10% compounded continuously. So R is equal to 0.10, which is 10%. My K is going to equal 5, which was given as well. And then I have to just substitute it in. So this is going to be between 0 and 5 of my function, which is this thing, 12e to the minus 0.4t minus 1.2. And then I'm multiplying it by e to the RT. I believe it's RT. Minus RT, okay? E to the minus RT, which is a minus 0.1. That was from the interest rate that we got up here, times t, dt. So this is the present value, okay? Now what happens, the reason why I multiplied this whole thing out earlier was because now I can just combine and add those two exponents together, like just the particular pieces, since this whole thing is multiplying. Remember the properties of exponents. If you've got the same base, you can take the exponents and just add them together. So in this case, this is the same as the integral from 0 to 5, 12e to the minus 0.5 t minus 1.2 dt, okay? Now, you could go through this whole process of u substitution, everything like that. I'm really not going to do that right here. I know that you probably at this point should feel pretty comfortable with that content. And if you don't, you definitely should go back in time. But what I'm going to do is I'm going to just go to Wolfram Alpha and I'm going to solve this equation just by putting it in. So let's go ahead and do that. Wolfram Alpha. I'm going to actually write it out a little differently. So you can do it using math mode right here, math input. I'm going to use just natural language. And the way you can do that is literally just typing in integral of, in this case it was 12e to the, what is it, minus 0.5. I'm going to use x here. Minus 1.2. Okay. From 0 to 5. All right. So first off, maybe double check it to make sure that it's correct. And in this case, it is. So here we're going to get about 6.64. Okay. So this is equal to 6.64. All right. The future value, this one's a little different. So we have to multiply E in front, E to the R times K, and K is going to be 5 here. So this is going to be 0.1 times 5, and then the integral of that exact same thing that we just had. So 12 E to the minus 0.5 T minus 1.2. I'm going to give you a little hint here. It's literally, we know that this thing right here is just 6.64, and so it's literally just 6.64 times whatever that is. So it's really, finding the future value once you found the present value is actually really easy, times 6.64. Okay, so I can literally go back to Wolfram Alpha here, and if you want, you can click that times E to the, what was it? 0.1 times 5, and you're going to get 10.94. So there you go. Sometimes working smart is generally the way to go on some of these problems, right? You technically could go through this whole process of integration again, but there's no point. So work smart if you have that capability. I hope you do. You got to this point, so you're doing something right. All right. I'm in deep trouble. I ran out of coffee, so it's not good. All right. Let's look at this next one. It says a 58-year-old couple. A 58-year-old couple are considering. That's a question. Ooh, is that grammatically correct? A 58-year-old couple are, or a 58-year-old couple is considering? I don't know. Let me know in the comments. 58-year-old couple are, according to the book, considering opening a business of their own. They will either purchase an established gift and card shop or open a new wine boutique. Who would want a gift shop if they're going to do a wine shop? That's so much better. Anyway, a gift shop has a continuous income stream with an annual flow rate of time t given by, okay, we've got two functions. So g of t is equal to 30,000. So it looks like this is like 30,000 per year guaranteed, no matter what. And it looks like the wine shop has some fluctuation in it based upon the year. I wonder why that is. There's got to be some like logistic reason why. E to the 0.08t. The initial investment is the same for both businesses, and the money is worth 10%. So R is equal to 0.10. Compounded continuously. Find the present value of each business over the next 7 years. Until the couple reaches age 65, of course. To see which is the better buy. Okay, so we need to find the present value. That means that, let's just do present value of, let's do the first one, g of t. So this is going to be the integral, and we need to do this over the, I should mention k is going to equal, what, 7? Yeah, k is equal to 7. Okay, k is equal to 7 years. So we're going to go from 0 to 7 of 30,000 e to the 0.1, man. And actually I think it's minus 0.1 t dt. Okay, so this is for the gift boutique. or the gift shop it's spelled SHOPPE. So it sounds very British. The gift shop. All right, so I'm just going to go ahead and evaluate this. Again, I'm comfortable at this point. Hopefully that you are aware of how a lot of this works. So I don't want to drag these things out. I know you're probably like, thank you. Thanks for not dragging this thing out. 30,000 e to the, I gotta remember what this was, minus 0.1. Yeah, we'll see what I think t works. Minus 0.1 t. There it is. Ooh. Oh, yeah, because I got to change my bounds. Duh. 5 years. I was going to say, that's not the answer I got. There we go. All right, 151,024. 151,024. 024, okay. And my fun writing horribly comes back. Okay. So that's for the gift shop. Let's look at the wine boutique. From 0 to 7. Okay, great. My terrible handwriting is coming back. I don't know why this does this. E to the 0.08 t times e to the minus 0.1 t dt. Okay. If you want really quick, this is the same thing as integral from 0 to 7 of 20. Oh, jeez, seriously. This is so annoying. 21,600. You can just add those together. So 0.08 and a minus 0.1. The difference is only going to be, 200ths. So, and it's going to be a negative. So it's negative 0.02 t dt. Or you can literally just punch it in and be lazy. So I might actually just do that. The number was 21,600 e to the what was it? Minus, I want to double check. Minus, good lord, 0.08 t minus 0.1 t. There we go. Let's just do that. Hopefully it gives us the correct answer. $21,600 from 0 to 7. It's so fun. Oh, you know what? It's point. Is it 0.0? Okay. 0.08 minus 0.1. I want to double check this. 0.08 minus 0.1. Did I literally do the math wrong when I did this earlier? Minus 21,600 e to the This is going to be so silly, but I'm totally doing it. You know, sometimes it's just one of those days where you're just like, to the 0 point. There's the decimal. Okay, it's 0.02. Yeah. So, okay. This is what I'm concerned about because I got a completely different answer. 21,600 e. So if I do, okay, 141,093. Remember that. I guess you don't have to because you can always rewind it. Oh, it's a minus. That's why. Okay, minus right there. Try this. Maybe I did it wrong. There it is. Okay, it is correct. So there you go. I must have just wrote it down wrong when I solved it last time. But okay, there you go. So this is going to equal whatever Wolfram Alpha says here. My notes are actually incorrect. 141,093. 141,093. So the question in this one was, which is a better buy? In my personal, professional opinion, obviously the wine one is way better, but, perks, I guess, side business perks there. But in this case, financially, if your only reasons are financial reasons, then the gift shop is probably the best way to go. So, in any case, that's how you go about doing these kinds of problems. So if you have any questions, let me know. Hope you have a good one.